Toggle an LED with a single button, on and off, true and false. Toggle an LED with a single button, on and off, true and false. Toggle an LED with a single button, on and off, true and false.
Good morning. In today's video, I have a circuit and code which toggles an LED on and off. The point is to turn an LED on or off using a single push button. And the essence of what's happening is that the state of this toggle state variable I created changes depending on the signal of the input pin. Allow me to explain the code line by line. Import rpi.gpio as GPIO. This imports the rpi.gpio library, which allows your Raspberry Pi to control the GPIO general purpose input-output pins. GPIO is just the name we will use to refer to this library in the code. I included this line just to show that the program is running. Here's import time. This imports Python's time module, which provides functions to pause the program, sleep, or measure time. In this code, time sleep is used to create delays for debouncing and CPU management. GPIO.setMode, GPIO.board. The Raspberry Pi has two ways to number pins: board or physical pins, and the Broadcom pins. This defines two variables for clarity and easier code updates. The input pin will read the button, the output pin will control an LED. GPIO.setup, input pin, GPIO.in. And this is configured with a pull-down resistor to keep the input pin normally low. So when the button is not pressed, it will read normally low. GPIO.setup, output pin, GPIO.out, configures the output pin as an output pin so you can control the LED. Toggle state equals false. This is the state that will toggle on button presses. Toggle state is a Boolean, true or false, that keeps track of the current on-off state of the output. Each button press flips the state. Last input state, GPIO.low, stores the previous reading of the button, helps detect transitions like a button press instead of just the current state. Try, while true, starts a try block to handle exceptions cleanly. While true creates an infinite loop continuously checking the button. Input state equals GPIO.input, input pin. Reads the current state of the button, GPIO.high when pressed, GPIO.low when not pressed. If input state equals equals GPIO.high and last input state equals equals GPIO.low, toggle state equals not toggle state. Flip the toggle state. GPIO.output, output pin, toggle state. Update output immediately. Time.sleep 0.2. Simple debounce delay. What this does it checks the rising edge, the button pressed but was not pressed before. If detected, toggle state equals not toggle state. Flips the state true to false or false to true. GPIO.output, output pin, toggle state, updates the LED/output to match the new state. Time.sleep 0.2 pauses for 0.2 seconds to debounce the button, avoids multiple triggers from mechanical bouncing. Last input state equals input state. This updates last input state to remember the current button state for the next loop iteration. This adds a small delay to reduce CPU usage. Without it, the loop runs as fast as possible and can strain the CPU unnecessarily. I had to scroll down. Except keyboard interrupt, print exiting program. If you press Ctrl and C in the terminal, a keyboard interrupt is raised. This prints a friendly message before stopping. Finally, GPIO.cleanup. Reset GPIO pins. Runs no matter what, normal exit or exception. Resets all GPIO pins to safe state, avoiding potential conflicts or leaving LEDs on. Well, thanks for watching, and
toggling LED with the single button on and off, true and false. Toggling LED with the single button on and off, true and false. Toggling LED.